So the goal of this video is to understand where the quadratic formula comes from so that we don't think it's some magical tool that solves problems. So in the previous homework assignment, you had to solve quadratic equations by using the method of completing the square. And what we want to understand is that the quadratic formula comes from completing the square on the standard form of a quadratic equation. So if you think about what we did when we completed the square, we rewrote the problem that we were working on. And then to make our life just a little bit simpler, we took the constant term and we got it over on the other side of the equation. So in this particular instance, if I had plus 5, I would subtract 5, and that would give me a negative 5 sitting over here. And I'd be left with a 2x squared minus 7x. So if we complete the square on the standard form of a quadratic equation, I would do all of the same things I did if I knew what the numbers were, right? So if this is ax squared plus bx plus c equals 0, my first step would be to take the thing that doesn't have an x and get it on the other side so it's out of my way, just like I did by subtracting the 5 over here. So I would probably take the c and subtract it from both sides. So I would get equals negative c, or the opposite of c, and then I'd have ax squared plus bx sitting here. And then when we were completing the square, what we recognized was that the completing the square process was predicated on having a leading coefficient of 1 on the x squared term. So if we didn't have a 1 there already, we did what we needed to do to get a 1 there. So in this case, I would divide everything by 2. So that my leading coefficient would be a 1. So 2 divided by 2 is 1, so I get 1x squared minus 7 halves of an x. And then we have some space left here for the completing the square process. So over here, if a isn't a 1, I'm going to divide everything by a, because a divided by a is going to be 1. So I'm going to get x squared plus b over a times x equals the opposite of c over a, whatever that number turns out to be. And then if we step back to the concrete example, what we did in the next step is we said, once we've got that leading coefficient of 1, take the coefficient on the linear term, the x to the first term, take that coefficient, so in this case a negative 7 halves, and then we took half of it, so we multiplied it by a half, and then we squared it. So we got negative 7 over 4, and if we square it, we're going to get a 49/16. And we took that 49/16 and we just added it to both sides. So I'm going to do the same thing here. I'm going to take the coefficient on the linear term, which is a b over a. So we're going to take the b over a, and we're going to halve it. So multiply it by half, and then square it. So we're going to get b over 2a squared, which is going to give us a b squared over 2, square it. 2 squared is 4, and a squared is just a squared. And then you take that after you square it, and you add it to both sides. So plus b squared over 4a squared, but we have to add that to both sides. So plus b squared over 4a squared. I'll move the plus a little bit closer to give myself some room. And then when you get this, you've got to combine these. So to combine them, you have to find a common denominator. So I'd multiply by 8 over 8 to get a 16 in the denominator. So I get negative 5 times 8's a negative 40 plus 49 is a 9. So I get 9 over 16. Just adding them up by finding a common denominator. And then over on this side we said, hey, we completed a square. Whose square did we complete? And the thing that goes in here with the x is whatever term wound up getting squared to give us the 49 over 16 that we added to both sides. So in this case it's a minus 7/4. So it's going to be the same thing here. I need to get a common denominator so I can combine those terms. So the denominator is going to be 4a squared, so I'm going to multiply by 4a over 4a. 4a times a is 4a squared. So I'm going to wind up with a 4a squared in the denominator, and I have a b squared. And I'm going to put it first just for style reasons. It's going to be b squared. He's plus, so the order I do him in doesn't matter. So plus b squared minus, and that's c times 4 times a, or minus if we put the number first and order the letters in the order they occur in the alphabet, using the fact that order of multiplication isn't going to matter. There I get a guy with a common denominator. And then whose square did I complete? Well, it's going to be x, and then I have to take whatever I squared to get the b squared over 4a squared. So that's going to be a plus b over 2a. And then once we get it here, we know how to dig the x out of this. It's the square root property. So we take the square root of the left side, and then we take the square root of the right hand side, and we know we need to go plus or minus. And so I'm going to do the same thing here. I'm going to go square root of the left side, square root of the right hand side, but I know I need to do a plus or a minus. And if we have the concrete example, we know the square root kills the squaring and drops out the x minus 7 over 4. Plus or minus, and then we usually simplify this radical. So square root of 9, if we can. So square root of 9 is 3. We put it in simplified radical form. Square root of 16 is 4. So I'm going to do the same thing over here. The square root cancels the squaring. X plus b over 2a pops out, equals plus or minus, and we want this in simplified radical form. The numerator actually doesn't simplify, so we just get the square root of b squared minus 4ac in the numerator position, but that denominator simplifies. The square root of 4 is 2, and the square root of a squared is just a. And if we walk back over here, our next step would be to get the minus 7/4 off of that x. So we would add 7/4 to both sides. So I'd get 7/4 plus or minus a 3/4. So I'm going to do the same thing here, except this is plusy, so I'm going to subtract b over 2a from both sides. So subtract b over 2a from the right hand and left hand side, plus or minus the square root of b squared minus 4ac, all over 2 times a. And then our last step here that we could take if we wanted to is we could say, hey, look, I have a common denominator. The 4 is the same. So it's going to be the numerator 7 plus or minus the numerator of 3. And so I can do the same thing here. I can say x equals, hey, the denominator looks like it's the same. It's just a 2a. But it's going to be the numerator negative b plus or minus the other numerator, which is the square root of b squared minus 4ac. And there is the quadratic formula derived from the process of completing the square. And so the only thing that we have to recognize is that this formula derives from the standard form of a quadratic equation, which means to use this formula, to use the a, the b, and the c, your equation has to be equal to 0 because the quadratic formula comes from a form of the quadratic equation that is equal to 0.